Welcome back to our sequence on environmental consequences of engineering design. In this session, we will look specifically at the power consumption involved in product use and the environmental consequences associated with what happens when the consumer consumes a product. The use or consumption of a product is the highlight of the life cycle, where the product achieves its benefit to society. But use and consumption is not without its own environmental consequences. While these consequences vary widely with different products, in this session we will cast a spotlight again on electronics, and in particular on the power involved in using a consumer electronics device. The environmental impacts of power consumption vary widely depending on the type of electricity used to supply the device. For example, burning coal to produce electricity hurts air quality, adds significantly to greenhouse gas emissions, and has a range of other equally negative environmental impacts. On the other end of the spectrum, wind energy may appear to do no harm, but no means of generating electricity is without some harm to the environment. And for this reason, it's important for engineers to design new, creative, and significant ways to continue to reduce power consumption as electronic devices, especially consumer electronics, continue to proliferate around the world. While consumer electronics seem mostly small and unobtrusive, their footprint on overall energy consumption in the home is quite the opposite. Despite the many advances in residential energy consumption, from better insulation in homes and correspondingly lower cooling and heating costs to energy saver appliances that abound in the modern home, consumer electronics have obliterated any overall savings or strides forward Americans have made in reducing their overall energy footprint. In fact, in the 21st century, we are consuming about the same amount of energy in the home that we were in the 1970s. Consumer electronics, including everything from televisions to smartphones, now consume about 12% of the electricity we use in our homes. Using consumer electronics costs us more energy than just about everything else in the home except cooling. And in cooler climates, consumer electronics may indeed surpass all other energy uses in the home. The good news is that the baddest actor in the consumer electronics power consumption arena is the analog television, which is largely being replaced by digital TVs. But never fear, an increasing suite of must-have consumer electronics are ready to fill in the resulting gap. Computers and digital televisions are the heaviest hitters on the power-hungry list, but the suite of little devices plugged in here, there, and everywhere in the average home can add up to quite a bit as well. Compounding the many and the power-hungry electronic devices and appliances we keep at home is the unfortunate fact that many of those devices are merely consuming power even when we are not using them. Some of this unnecessary or vampire power consumption comes from convenience. For instance, we want the TV to turn on right away. Some of it comes from design artifacts. For example, the battery charger consumes power even when no battery is plugged in. And some of it comes from engineering design, in that not all the components on our computer that could sleep are sleeping in sleep mode, and so on. But regardless of the reason, unnecessary power consumption costs the environment. More so in areas where coal is used to make electricity, but even so in areas where water or other renewable energy is used to make that electricity. Consuming power and electricity simply costs the environment, regardless of how the power is supplied. And the vampire is especially greedy among consumer electronics. Televisions, smartphones, computers, and the like are responsible for over half of what the typical residential home soaks up in vampire power. Unnecessary and wasted, vampire power accounts for a lot in our electronics power budget. Have we convinced you that the vampire in your house is not only sucking money out of your household budget, but also bearing a load of environmental consequences as well? As engineers or others associated with product design, what do we do about it? Well, at a base level, vanquishing the vampire requires understanding what all electronic circuits in a product are doing and how they interact. Without knowing this, as well as the power involved in each circuit, it's impossible to banish vampire power consumption. Knowing fully how circuits interact allows the engineer to optimize how many can be put to sleep, to idle, to standby, or other low power mode of operation. Knowing the actual power involved in each circuit gives a priority to this optimization process, so that power-hungry components are vanquished during idle and sleep first, before moving on to circuits or components that are a negligible part of the power use process. A number of more creative approaches are also available to the engineer in reducing vampire power consumption. In this example, a low power sensor front end is attached to a power-hungry electronic device, such as a set-top box for a television. Instead of keeping the set-top box in a power-hungry standby mode, ready to deliver television at the touch of a remote control button, a sensor can detect the presence of a potential user lurking in the vicinity of the television and trigger standby mode, thus saving the power that would otherwise be consumed in standing by all the time. Through the integration of sensors and sensor systems into the gateway to using in power consumer electronic devices in the home, significant power consumption savings can be realized. Moving beyond vampire power consumption, which has plenty of design opportunities for reducing overall energy usage in electronic devices, we can take a look at similar opportunities for reducing power consumption and the environmental consequences that result from these electronic devices through the active, in-use mode of operation. Within the proliferating number of little devices we use in the home, there is immense opportunity to integrate new little devices within existing devices in order to avoid the need for redundant microprocessors and other computing centers to process the data provided by these devices. For example, NASA has developed a gas sensor module that can be fully and readily integrated into a smartphone to take advantage of the intelligence and electronics already available in a smartphone. This type of design, especially considering the high percentage of power consumption involved in converting data to digital equivalents and processing that data, helps to reduce active power consumption by quite a lot. Similar to leveraging existing devices in the design process is combining multiple devices into one. For example, a product by Samsung called SmartSense allows the user to detect multiple environmental parameters, proximity, vibration, and temperature, all in one device, which reduces not only size and volume, but also the power demands by the integrated system design. Design for smarter and reduced power consumption can also involve creatively designing intermediate power consumption modes, even when the device is active and in use. For example, smart lighting systems can not only turn on when someone is in the room and turn off when the room is empty, but can significantly reduce lighting and associated power consumption when the sun is out, reduce it not so much in cloudy conditions, and so on, to accommodate the contribution of natural light to overall lighting in both indoor and outdoor space. In summary, power consumption is an aspect of design that engineers, as well as others involved in product design and maintenance, have many and varied opportunities to reduce. Whether by reducing what a device consumes when it isn't doing anything useful, vanquishing the vampire draw of consumer electronics, or making those same cuts in power reduction when the device is active, opportunities for reducing power are as varied as colors in the rainbow. Power reductions in any way, shape, or form ultimately reduce the environmental consequences of using electronic devices, whether through the environmental costs of producing electricity or through the environmental impacts of the billions and billions of batteries that we use and dispose of every year. This concludes our snapshot of the environmental consequences of power-hungry consumer electronics. Thank you for joining us today. We certainly hope that this look into the world of power consumption has provided insight into how the engineer can reduce the impacts of engineering design during product use, and that you'll join us again as we look at other examples of environmental consequences in this series on real-world considerations in engineering design.